Hello, my name is Kylie Barber. I'm a rising junior at Penn State studying mechanical engineering and mechatronics within the Schreier Honors College. This summer, as part of the Robotics Institute Summer Scholars Program, I worked to design a compliant bistable origami swimmer. This project was in collaboration with my twin sister, Kylie Barber, as well as my advisor, Dr. Zainab Tamel. In this video, I will focus on YoFin, which is the actuation mechanism of YoFin, the swimmer that we created. It's important to understand some background terminology in order to better grasp the research I performed. Compliant mechanisms are mechanisms that contain flexible linkages instead of rigid components. This gives the mechanism some bending and elasticity that we can take advantage of when designing, and it also gives it better performance and is less likely to break or be missing a component. Another important component is origami mechanisms. This is derived from the ancient Japanese art of paper folding, which was originally just an art, but now is used often in engineering to allow for new and interesting geometries to be achieved. Another important term is bistable. So bistable mechanisms have two stable positions where the potential energy is at a minimum, and they can snap between those two positions. For the design of the actuation mechanism, we started by prototyping in paper and then moved on to designing in CAD to adjust framing and linkages. This mechanism was called YoFin. It also shows potential for depth control in the future. For this mechanism, we attached a servo motor and also connected it with our other mechanism, diamond fin, which has a more fin-like aspect to the front, where those fins can open and close, causing propulsion. YoFin is a serial 6-bar linkage, and it also has bistability in the top and bottom positions, as you can see in the pictures underneath design. This YoFin was combined with diamond fin to create YoFin, the swimmer that we made. YoFin is a compliant origami robot, and it can swim at a rate of 2.1 centimeters per second. It is cheap to manufacture and create because of the manufacturing process that we used. This manufacturing process is known as lamination. It involves combining rigid, flexible, and adhesive materials together in order to create an origami design. These materials are laser cut with different gap sizes on the laser cutter, and then pressed together, and then cut with a final pass with the laser cutter to release the mechanism. To assemble the mechanism, once it is released, we simply fold it up and glue it in place. For testing, we took YoFin and put it in an aquarium full of water. The mechanism was sinking originally, so we added foam to it in order to allow it to be buoyant and swim across the tank. We then actuated the mechanism, allowing it to move across the tank and timing it as it did so. Some challenges we faced with this project were delamination, which is where the materials were peeling apart while it was swimming. To combat this in the future, we want to add on some better adhesive within the mechanism and also consider changing out the rigid material so that it doesn't flex too much. This swimming robot can be used for education to teach design and manufacturing of origami robots. Since it is also a swimming robot, it could also be used to demonstrate properties of fluid mechanics and swimming techniques for others to learn. In the future, we would also like to add sensors to this design so that we can perhaps explore the ocean autonomously, since a lot of the ocean is still unexplored and represents a great opportunity for scientific discovery. Here is a video of our swimmer in action. You can see it swimming across the tank. It's not getting full closure of the fins, and this is something we want to work on by adjusting the actuation mechanism as well. I'd like to end by saying how much the RISC program has meant to me. I have done research at Penn State before, but Also getting to research at Carnegie Mellon with a different university was an eye-opening experience because I could network with so many different faculty members and also meet many of my different colleagues who were also here in the BRIS program. There were some international students, some students who were also from Pennsylvania, and it was a great opportunity to get to meet new people and explore my research interests. I also got the opportunity to learn about grad school, and I'm really excited about what the future in robotics can hold for me, and I'd love to share that knowledge with others as well. Thank you for listening to my presentation. I hope you learned a little bit about origami robots in the RIS program, and thank you.